Hello everyone. In this session we are going to find the roots using the interactive method of the Newton's Raphsons. So in this we are going to approximate the roots of the given functions. So, and the function that you're going to use, remember to get the approximation of these, we can say that our x n plus 1, that is our approximation, is always equivalent to x n, that is the one that we are approximating, the one that is below, then minus the function of xn divided by the first derivative of that function, So in our case here, our fx here, our function here is equals to x cubed, then minus 7x squared, then plus 5 is equals to 0. So now our first derivative of this function, which is f1, then here we have x will be equivalent to, we differentiate this equation, so we shall have 3x squared, then minus 14x minus 14x. So now remember here we want to approximate the values or the roots in between the intervals of 6 and 7. So we can take our first iteration, that is iteration 1, and say that this one we can take our initial value being 6.5, because the 6.5 is in between those two, and in this case we can be able to approximate the first root, and to approximate the first root we know that our x1 will be equivalent to now our initial cost, which our initial value, which is x0. Then from here now we subtract the x initial value cubed, then minus 7 multiplied by initial value squared, then added to 5, and then this we divide by 3. Remember this one was our first derivative equation, which is 3, then multiplied by our x initial squared, then minus 14, then multiplied by our x initial. So that if we substitute now this, we have our x1, our first approximation of this root becomes x1 is equals to, remember our xo is equivalent to 6.5, then this minus, here we are going to have 6.5, this is cubed, then minus 7 multiplied by 6.5 squared, then plus 5, then all these we divide by 3 multiplied by 6.5 squared, and then minus 14 multiplied by 6.5. So in that, if we work out this, we are going to have our x1 equivalent to 6.95 1048 then 951. So that is our first approximation of the root of that. So the next thing, we can get the second approximation, and for us to get the second iteration, we know that we are going to use our value of x1. So we are going to have x2 will be given by x1, then this we minus our function, which was x1 cubed, then minus 7 x1 squared, then plus 5, and then we divide here by our first derivative here, which was 3. Then we shall have x1 squared, then minus 14 x1. So our x1 we have already calculated 8 to 6.95, so we substitute, and if we substitute that, we can get now our x2 is equivalent to 6.89557 So that is our second approximation. So, and for us now, we can take this second approximation to use it. We use it to get the third approximation also. So we know that our third approximation, which is x3, this one will be given by, we take x2, the second approximation, then we subtract our function equation that we have, which was x2 cubed, then minus 7 x2 squared, then plus 5, and then this we divide by 3 x squared, that is x2 squared, then plus 14 x2, and if we substitute that, we get our x3 will be equivalent to 6.899422, then 504. So that will be our third approximation, and remember, we can still use the third now to get the fourth one. We can be able to say the fourth one will be given by our x4 will be equivalent to x3 now, and then minus, remember we had x3, then 3, then minus 7 multiplied by x squared 3. Remember, this is x3, all of it, the one that we have our third approximation, then plus 5, then we divide this by 3. That is our first derivative equation, which is x squared 3, then minus 14 x 3, and if we substitute this, we shall get our x4 equivalent to 6.89482225. And remember, still we can use this is our fourth approximation. We can get even the fifth approximation by saying our x5 here. Remember, we are going to use the fourth approximation here, which will be x4 x4, then minus, here we are going to have x squared 4, then minus 7 x4 squared, then plus 5, then all these we divide by 3 x4 squared, then minus 14 x raised to power 4. So, and here we can, if we substitute, we are going to get x5, or the fifth approximation, as equivalent to 6.894822. So that is how we can approximate the root of a given function using the Raphson or Newton's Raphson method of iterative method. And that's bring us to the end of this session. I was your trainer, Maurice Morini. If you found this video of importance to you, consider subscribing, like, and share it to many platforms. Thank you.